Hi everyone, this is Janine Ko, aka Janine the Tutor. As you all know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of one class, we are very fortunate that we are able to adapt to the situation quickly. And because we want to help students stay on top of their studies, that's why we're running daily and free classes for math and chemistry from grades 11 to first year college and university. In addition, we are also offering and giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will be going over advanced functions or pre-calculus. And we're studying this course collectively because I just think that the best way to learn advanced functions or pre-calculus is to really combine all of your types of functions and be able to evaluate them. Can I get a yes if you can see my screen? And if you can hear me coming through as well? Okay, so let's begin. So the first question we need to figure out whether the function is even, odd, or neither, right? So just as a recap, first of all, how do you know if a function is even versus odd, right? So if a function is even, that means algebraically, you're going to have to plug in f of negative x. So if it's even, if you plug in f of negative x, you need to have f of x. So that's when it's even. And if it's odd, you need to plug in f of negative x as well. But instead of having f of x, you need to have negative f of x. Does that make sense? And the reason for that is because if you're looking at an even function, so say for example, let's start with the basic. We have y is equal to x squared, which is a parabola. We know that this is an even function. So you're going to have this graph right here. So this is y is equal to x squared. And if you think about the symmetry, there we go. So this is an even function. So if you think about the symmetry, that means your function remains unchanged if it is reflected on the y-axis, right? So if you think about this y-axis as sort of like a mirror, so when you flip this part, right, it becomes the exact same reflection, right? So it's symmetry around the y-axis, but for an odd function, let's say you're looking at y is equal to x cubed, which is a cubic function. Okay. So your symmetry is actually 180 degrees, right, over here. And you have a point symmetry, to be specific, right here. So when you kind of rotate this, right, 180 degrees, so you're looking at from here, rotate that until here, right, 180 degrees, you're going to see that your function remains unchanged. So that's the difference between even and odd functions. And that's why you have this positive symbol right here versus the negative sign right here. Okay, so hopefully that was clear. But for this three questions, A, B, C, all you have to do is really evaluate whether you're going to have f of x as a result, which is the exact same thing as your function, versus if you can take out the negative sign and then you're going to have your function, f of x. Okay, and if it's neither, that means it's not going to be any of the two, right? So let's start off by plugging in f of negative x right here. Okay, so we do have 1 over negative x, and then you need to cube this, right? Plus 1. So if you think about cubing negative 1, right? Because this is a negative 1 coefficient, we can actually say that this is going to be 1 over negative 1 cubed. So we're taking out that cube, and then we're left with x, right? plus 1. Does that make sense? So this should still be cube, right? Because we're still copying that cube because it's raised to 3, but then we're taking out the negative 1, and as a result, we know that any negative number raised to an odd exponent is always going to be negative, right? So therefore, we're going to have negative, right? So this negative 1, you can have that outside of x cubed. So you're going to have x cubed, and this is going to be plus 1. Okay, so if you think about this negative x cubed, right, this is not really outside of your function. It's actually just beside x cubed, right? Because if you have to take out the negative sign or factor out the negative sign, you're going to have negative, right, 1 over x cubed minus 1, right? Because the negative sign gets distributed if you have this right here, so you're going to get negative x cubed plus 1. So as a result, you're going to say that this function is neither. And why is it neither? Well, if you look at your function, right, your f of x originally is 1 over x cubed plus 1. And this negative sign right here, if it's odd, that means you're going to have this negative sign outside, but you need to exactly have the same function, which is f of x, right? But is it the same function? No, because you have a negative 1 here as opposed to plus 1. That's why it's neither. Okay, hopefully that makes sense. Moving on to part B. We have 2x raised to the power of 4 plus 3x squared. So when you plug in negative x, so same thing, raised to the power of 4 plus 3 times negative x squared, you're going to see that you have even exponents, right? So what's the rule when your coefficient is negative, right? Or any number really, when you raise it to an even exponent, right? It's always going to be positive. Okay, so as an example, if you type in negative 2, right? We know that, let's just keep it as negative 1, just so it's simple. Okay, so this is negative 1. If you raise this to an even exponent, let's say 4, right? Type this into your calculator, you're going to get 1, right? So that means anytime you have a coefficient or a number raised to an even exponent, it's always going to be a positive number. So in that case, you're going to get exactly 2x raised to the power of 4 plus 3x squared, right? And as you can see, 2x raised to the power of 4 plus 3x squared is exactly the same g of x, right? To begin with. So therefore, since we know that g of negative x is equal to g of x, we can say that our function is even. It's not too bad, right? All you really have to do is plug in your negative x. Okay, so moving on to h of x, which is 1 over x cubed plus x raised to the power of 5. So here's the thing, because you have raised to the power of 5, it gets a little bit tricky, but you're going to do the same thing so it's the exact same thing as the other two that we did. So you're going to plug negative x. So you're going to have h of negative x, and that's equal to 1 over negative x cubed, and this is going to be plus negative x raised to the power of 5. Okay, there we go. So as a result, right, remember what I said about if you have a negative coefficient, you're raising it to an odd exponent. Therefore, the number would remain negative, right? So that's what we're going to do. So we have 1 over, this is going to be negative x cubed, right? And then we have negative x. Okay, so from there, we can take out this negative symbol or negative sign, right? Such that this is now going to be negative, right? And by the way, because you have 5 here, we can say that this is negative 1 raised to the power of 5. Because remember, you're taking the negative 1 out from an exponent of 5. So you need to make sure you have that 5 there. And then you can rewrite this as 1 over x cubed plus x, right? raised to the power of 5. Okay, so there we have it. And then now you can see that again, I've probably said this so many times now, but if you have a coefficient that is a negative number and you're raising that to an odd exponent, that means it becomes negative, right? So you're going to have this negative 1 here because of this odd exponent, and then you're going to have 1 over x cubed plus x raised to the power of 5. So as you can see, you have a negative sign out here when you plug in h of negative x, right? You're getting negative of h of x, which is an odd function, right? Because going back to this, what did we say? If it's an odd function, if you plug in negative x in your function, if you have a negative sign and if you're getting the same exact function, which is f of x, you're going to have an odd function. Cool. Again, as a reminder, all of my sessions are recorded, so you don't have to quickly jot everything down. Just take a seat, take your calculator out, plug in the values, calculate them with me, and just pay attention. So for number 2, it says graph the following functions. You have y is equal to negative x times x minus 3 times x plus 4. Okay, so we're just going to do a recap with multiplicity and degree, and also the sign of your leading coefficient. So those are the 3 things you have to remember if you're graphing functions, and specifically they're polynomial functions, right? So this is a polynomial function. So first, let's identify 3 things as I mentioned. So if you're looking at this negative sign right here, that indicates that you have a negative leading coefficient, right? And you're probably wondering right now, what does the leading coefficient and its sign has to do with drawing or graphing the function, right? So if it's a negative leading coefficient, so we're going to have that right here. So leading coefficient. So if it's a negative leading coefficient, that means when you're graphing your function. So for example, if you're looking at a linear function, which is y is equal to x, say for example, versus y is equal to negative x. So we know that if you're graphing y is equal to x versus y is equal to negative x, if it's a linear function, that means your line is passing quadrant 3, right? Because this is quadrant 1, 2, 3, 4. Versus something like y is equal to negative x, which is quadrant 2 and quadrant 4. Does that make sense? So the negative leading coefficient or the positive leading coefficient would determine whether your function is passing quadrant 1 and 3, if it's let's say y is equal to x, versus quadrant 2 and 4 when it's a negative leading coefficient. Same thing really applies for example, y is equal to x cubed, right? Which is what we know is an odd function, right? So we have something like this. So we know that it's quadrant 3 and quadrant 1 when it's positive, and if it's negative x cubed, we know that this is quadrant 2 and quadrant 4. And guess what? It's similar to y is equal to x squared, right? So let's just scroll down just to see and compare them. So y is equal to x squared. This is going to be on quadrant 2 and quadrant 1, right? And if you have y is equal to negative x squared, you're going to have that on quadrant 3 and quadrant 4. Does that make sense? So it matters where you're going to graph that. Okay, so I can erase this now. So that's for the sign of the leading coefficient. So let's move on to multiplicity versus degree. So you've probably heard what multiplicity is, and also zeros, right? Zeros and multiplicity are related to one another. So for example, you're looking at